Welcome to this course, Introductory Statistics 1. My name is Salas Kujo Baji. I'll be taking you through this course. Basically, this course is about the basic concept of probability. We have 6 units to deal with. Without much ado, I would like to begin with the first unit, Unit 1, which has 6 sections. So Unit 1, Combinational Analysis. With Section 1, Fundamental Principles of Counting. By the end of this session, we should be able to state the fundamental principles of counting and explain those principles, give at least 2 examples, and also how we can apply those principles of counting, analyze problems, and identify tasks in them. Let's get deeper. Suppose I have X number of trousers and Y number of shirts to dress up with. Well, those X number of shirts and X number of trousers and Y number of shirts are going to give me a different outlook or different appearances. So how many appearances will I have if I were to use those X number of trousers and Y number of shirts? Well, realize this task can only be accomplished by me wearing the X number of trousers followed by the Y number of shirts. And in this case, I'm going to have Y times N or X times Y, different ways of dress up. You get it? So I'm going to have X by Y different ways of appearance, so to say. So you realize that this type of counting, by combining one element with another one, is what we refer to as fundamental principles of counting. And this principle can be used for counting in probability theory. Maybe we would like to take a concrete example to see. Example 1. Suppose I have 2 pair of trousers and 3 shirts, assuming that each pair of trousers can be worn with each shirt. How many trousers shirt outfit do I have? Now, to make this more easily for us to understand, let's identify those 2 trousers as being the color of black and brown. And let's identify the colors of those shirts, possibly white, blue, and yellow. So if I pick the black trouser, I could wear the white or the yellow or the blue shirt on them, giving me 3 different appearances. And when I pick the brown trouser, I could also wear the white, the blue, and the yellow shirt on it equally, giving me also a 3 different appearances. In all, I'm having 6 different appearances. And how do we arrive at this 6? That is, we multiplying the number of trousers I have by the number of shirts. As you can see, that is 2 times 3. That will give us the 6 different trouser outfits that I can choose from. Let's move on with more example. Example 2. How many number of 3 different digits can be formed by choosing from the digits 3, 4, 5, 6, 7, and 8. Now, how can we carry out this task? Now we are forming 3-digit number. So what it means is that we can break this problem into 3 tasks. What are the tasks we are talking about? By selecting the 100th digits, the 10th digits, and then the ones. Now I have 6 numbers. So if I were to choose the 100th digits, I have 6 choices to make, 6 numbers to select from. So I have 6 different ways or 6 different choices. That's selecting the hundreds. Now, assuming that we've done with that selection, now the next to choose from is the 10th digits. So one number is gone as we select the 100. So how many numbers will be left for us to select the 10? That will be only 5 numbers to select the 10th digit from. And we move on to the 1st digit. We'll be left with what? 4 numbers to choose from. So in total, we're going to have the 6 times 5 times 4, which equal 120 different 3-digit numbers to form. Hope you got the point clear. Yes. Maybe let's move on to another example to get the concept clearer. How many numbers of 3 different digits can be formed by choosing from the digits 3, 4, 5, 6, 7, and 8? But listen to the last part of the question. If the numbers can be repeated. Unlike the previous example, that example 2, the numbers could not be repeated. So once one number is picked, it reduces the total number of numbers we have there. But with this, we also have 3 tasks to carry on this, despite the repetition. So we need to select from the 100 digits, or you select the 100 digit, the 10th digit, and then the 1st digit. Yes. So how many choices do we have to select from these numbers? What will I have? I have 6 choices to make to select the 100 digits. Because the number could be repeated, what it means is that I can still choose the same number again. So selecting the 10th digits, I still have 6 numbers to choose from that have 6 ways, because repetition is allowed. And selecting the 1 digit also, I still have 6 numbers to choose from. Yes, in conclusion, what will be our final solution? So we're going to have 6 times 6 times 6 equal 216 different 3-digit number to select. So you see, these are some examples of fundamental principles of counting. Yes, we're able to learn these fundamental principles of counting as a review. And we have seen examples of those principles, and we're able to analyze the problem involving those principles. Thank you.